Hey guys, my name is Matthew Connolly, and today I'm going to be talking to you about WebRTC, audio and video communication in the browser. So Web Real-Time Chat, RTC, it's like an acronym. It's a set of JavaScript APIs that allow us to have immediate communication between peers or browsers. And there's three main APIs that I'm going to go over today and show you some code related to it. There's media stream, which is essentially when the browser is requesting access to your webcam and your audio. The RTC peer connection, which is how you actually connect with another browser. And then there's the RTC data channel, which is just a means to send any really arbitrary data between those two channels now that they're connected. Coming into full stack, I was kind of interested in, I wonder how browsers so seamlessly connect with each other, and we're able to talk on video conferences or like whether it's the video itself or the audio itself. So when we came to the WebSocket workshop, I thought I found the answer, and it essentially to review, WebSockets create this persistent connection between the client and the server. The client doesn't have to keep sending a request, and the server doesn't have to keep sending responses. It's this persistent connection that's established once the server just sends this kind of handshake, which is upgrading the HTTP. So as you remember, we were able to draw on one computer, and it would show up very quickly and seamlessly on our partner's computer, and that was able to just create this very quick transfer of information. But it turns out that there's actually a better way to connect with someone on a browser when it comes to video and audio, and that's what WebRTC aims to do. Just a reminder of WebSockets, essentially you're transmitting a message, and then once that's hit, it gets relayed to every other client, assuming that's how you set it up. But what WebRTC does is that the server connects the client directly to the other client. This is very useful for video and audio communication, because as you can imagine, just having even like a 1 second or maybe 1.5 second delay when you're talking with someone online is kind of awkward. Same if you're like playing a game or something. You really need like super fast relay of information. So I'm going to go into exactly how this works. So the first aspect of it is the media stream. So that's essentially how the browser is requesting access to your input devices. So as you can see here, I'm sure you guys have seen this at some point. And the great thing is WebRTC is built into the browser, so that makes it like super easy. So you could just write some JavaScript in order to get these get this stuff going. So as you can see, the browser is requesting access to my camera through this command down here, and I'm going to show you guys some code that has that. Great. So as you can see here, the code we just saw on the previous slide is requesting some constraints. So as we can see, the constraints are defined as audio false, video true. So what I would imagine is happening here, and we'll see an example of it soon, is that I'm probably going to be transmitting my video or just my video to a browser. And then it looks like it's a promise, right? So there's a success handler that once it gets access to my device, it's going to start streaming my video. So let me show you an example of that. So it looks like it's asking for access to my camera. I'm going to allow that. And I should pop up right there. Hey, what's up? And there's also a few other cool things going on here. It looks like there's some filter stuff going on here, and there's also a canvas where it looks like it's going to draw my image. So what I would imagine is happening is I could filter myself, right, with some CSS filters, nothing too crazy. Oh, that's horrifying, and we'll take a picture of that. Great, that's forever on the full stack YouTube. Great. So that's cool. Just that's the first aspect of RTC, just getting access to the camera. Let's get off that. Sweet. So next is the real meat of RTC, which is the peer connection, right? So essentially, you are talking to your server, and you're like, hey, server, I want to directly communicate with client number 2. And the server's like, yeah, sure. Let me help you facilitate that. So essentially, the process for how this works is that now that you have access to the media stream object, you are essentially sending that to another peer using like an SDP negotiation, and this is just like a kind of like a standard protocol for sending information about your kind of like the client. So it has stuff like info on you, like the peer number 1, the media codec, the stream info. It takes care of compressing and decompressing the audio, the video and audio, as well as like packet loss and echo cancellation and stuff like that. So essentially, what the process is, the first peer they get the media stream object. Then using the add stream API, they're able to generate an SDP, and you offer that to the second peer, and so that gets sent over. And the second peer goes through a similar process. They essentially, then they get that SDP and they are expected to send an answer back, which is essentially they go through the exact same process for the most part. So it's sent back, the first peer receives it, and then you can enjoy your audio and video communication. Now this was a bit of a dumbed down kind of like line that showed the connection. There's probably more stuff going on behind the scenes, but it's kind of complex for just like a 10-minute tech talk. It's about NAT traversal, which is essentially like, all right, now I'm peer number 1, but I have this firewall and a NAT in the way, so I have to pretty much figure out what my public address is, because I have an individual API, but I have to figure out what the public one is. So maybe I'll ping like a stun server that will give me that public address, and then create like a pinhole in my firewall where the second peer can get back to it. And this stuff it goes way deeper than that, but hopefully that's kind of like a broad overview of what's happening. So essentially, you as the person, as the architect for this, you have to consider making like a relay server, and this might also come into use if you're doing like conferencing, because as you can imagine, if like you're connected to a lot of other browsers, like it creates this huge mesh. So if you're doing like a conference, like if you're connected to like 20 other people and then the second person is connecting to 20 other people, it gets ridiculous. So you would have maybe like a relay server that kind of just takes care of that, facilitates all that. So the takeaway is that WebRTC comes on a browser and it's easy to access, but there's pretty much elements you need to structure on the server side. So let me show an example of the code of what the RTC connection is. So it starts with adding a stream, but I believe on here it's called on track. Yeah, so essentially on track is grabbing the, it's just making sure you have the media object, and then it creates the offer, which let me just traverse through this. Yeah, so the first person creates the offer, and then it's sending that SDP information to the second person, who is then creating an answer. And there's a few other things going on here that's more related to the NAT traversal, but I'm not going to get too deep into that. So let me show another example here. So first, the browser gets my media, which we'll do here. And this is going to seem a little weird, but because I'm just doing this on my own. But imagine these two boxes as like other clients. So it's just going to call me like twice. So yeah, hey. So imagine this is like a kind of like a web conference, right? Cool. And then the RTC data channel. So once you have this peer-to-peer connection, there's a few advantages you have. There's more privacy, lower latency, and basically there's more security because you're not communicating through like a server. Your messages are going directly to the client. So it is indeed more private, so you might as well take advantage of it. There's also reliable and unreliable ways of sending, and that's not necessarily like unreliable isn't necessarily bad, but of sending this data. So you can imagine for if you're sending like files, you'd want to use a reliable way to send the data because you don't want to lose any packets or anything during the file transfer because then the file will be useless. But if you're playing a game, you can lose frames and you get more velocity, so it goes a lot faster. Yeah, it's just a really cool way to just, now that you have this peer-to-peer connection, to take advantage of that. I think WebRTC just in general is like a really cool way to just continue to foster connection between people online. It's like a more intimate kind of way of like communicating and just ensuring really fast things. And there's a lot of cool things you can do with it. So I was going to show something that Google made a few years ago that is essentially it's a game and it's like air hockey, except the backboard is like someone's face. But it's not going to work because I would like to attribute this to maybe WebRTC upgrading over the years. They have
a console error here. Failed to execute create offer on RTC peer connection. Their callback provided as parameter 2 is not a function, so they
Google did a bad thing here. So it's the whole point of this was to like show the purpose of WebRTC and just what it can do. So that's unfortunate, but I'm sure you guys at least just want to see what the game is. So I'll just play locally against the default opponent, which I think is like a bear. So so you're essentially, imagine that was like my opponent's face right now. Yeah, really kind of fun, right? You could like psych them out. So that's pretty much the general overview of WebRTC. There's a lot more to it, but I was hoping to give this presentation because I know CAPTCHA's coming up, and I was hoping to offer some useful tools that you guys might be able to use in your project. So yeah, thanks guys.